Hello, folks. Professor Miller here, and today's video lecture is on the topic of logic and specifically on categorical propositions. This is part one. I will do another one shortly, which deals with additional information about categorical propositions. But for now, I want to talk about standard form categorical propositions. Uh, Logic, as it is understood by philosophers, was first constructed by Aristotle almost about 2,400 years ago. And then his writings were lost for centuries. In the Middle Ages, they were rediscovered, and philosophers began looking at them and dissecting them, arranging them. And eventually, in the 1800s, additional work was done, uh, which brought about what's called modern logic or Boolean logic from George Boole. But anyway, philosophers agree, modern and ancient, that there are four basic types of categorical propositions. Now, what is a categorical proposition? A categorical proposition is simply a statement that links two classes of things, a subject class and a predicate class. Okay, so um, for example, if you say all men are mortal, the subject is men and the predicate is mortal, things which are mortal. Okay, so philosophers agree that there are basically four basic standard form categorical propositions. The A proposition, or the universal uh, affirmative proposition, is A. It's called A. I'll explain that in a minute. And this says that all S, all subjects, whatever they are belong to the P class. All S are P. All men are mortal. All dogs are mammals. That's the A proposition. The E proposition is the universal negative, which says no SRP. For example, no dogs are fish, or no fish are mammals. In other words, when you're saying that no dogs are fish, it means you have the dog class and you have the fish class, and they do not interact at all. Now, the third type of proposition is the I proposition, which is the particular affirmative, which means some things, some S, are P. Some dogs are black, or some dogs are things with black hair. And the O, finally, the last one, is the O proposition, which says some S are not P, like some dogs are not black, or some dogs are not things with black hair. So, first of all, why are they called A, E, I, and O? It's easy to remember because they're the first four vowels. But the reason is that in the Middle Ages, when people were drawing this up during the Renaissance, I should say, uh, they were speaking Latin, and the word affirmo, which means to affirm, which is to be positive, is affirmo. The first two vowels are A and I, affirmo, A, F, F, I, R, M, O. And nego means to deny in Latin, and the vowels there are E and O, nego, N-E-G-O. Now, you can take these statements, these propositions, all SRP, no SRP, and so on, and you could use Venn diagrams to indicate what they're saying. So a Venn diagram is simply a diagram which shows how certain categories or classes of things relate to one another. So here we have all SRP. You have an S circle and you have a P circle, and they overlap. And you'll notice the left side of the S circle is all darkened. That means there's nothing there. It's completely darkened. Now, in mathematics, they sometimes do the opposite. The darkened spot means everything is there. But in logic, it means no, nothing is in the darkened spot. So all the things that are S are actually found within the P circle. So all things of the S class are part of the P class. There's nothing that's S which is outside of the P class. And the E class is similar, that in the sense that the darkened spot says there's no S that are P. So all the things in the S class exist outside and away from the P class. So here you can say all dogs are mammals. So those are, if S is dogs, then all the dogs are in the mammals class. So all the dogs are here. Now, not all the mammals are in the dog class, but all the dogs are in the mammals category. And over here, if you say no dogs are fish, then there's no dogs and fish in the same area. They're totally separate. So that area between them is darkened, meaning there's nothing there. There's no contact between dogs and fish. Now, the I, or the particular affirmative, states that some S are P. Now, you could say, for example, some dogs are black, or some dogs are things that have black hair. So that means that you have dogs, subject S is dogs, the predicate is things that are black, and there's at least the X here indicates that there are some dogs, meaning there's at least one dog which has black hair. There could be many more. It doesn't say anything about the other dogs who are not there. It just says there's at least one dog which is in the P category, meaning it's in the P class, it has black hair. Then over here, the O, the Venn diagram for this is the X is in the S part, and there's nothing else in the P, or, I mean, well, the other parts are not shaded in, meaning that there are some S, which may be P, we don't know, but for sure there's at least one dog, in this instance, there's at least one dog which does not have black hair. Okay, so all these Venn diagrams were originated by John Venn a couple hundred years ago, 150 years ago. Now, when philosophers or logicians are thinking about these categorical propositions, they're basically concerned with three attributes of these things. Number one, quantity. Are they universal or are they particular? Okay, so the A and the E are universal statements. They're talking about things, all the things that belong in this subject class. All men are mortal, or all no dogs are fish. So the first thing is quantity. Is it universal or is it particular? Is it some dogs or some S, or is it all? The second thing they're concerned about is quality. Is it positive or negative? So the A and the I are obviously positive. We're saying all men are mortal. Some men are definitely mortal. And the E is a negative quality. There are no dogs which are fish. And there are some dogs which do not have black hair. So we have quantity. Is it universal or particular? And quality. Is it positive or negative? And finally, philosophers are also concerned about distribution. And distribution refers to whether or not what you're talking about refers to the entire class of what you're talking about or just a part of it. So obviously, the A statement, all men are mortal, it's referring to all men. So therefore, the subject term is distributed. It means when you say the subject term is distributed, it means you're talking about everything in that subject class. You're talking about all of it. So A statements, A propositions always distribute the subject term. E propositions distribute both subject and predicate, because you say no dogs are fish, then you're talking about all dogs. Among all the dogs, none of them are fish. And at the same time, among the fish, none of those fish are dogs. So both the S and the P, the subject and the predicate, are being discussed here. Um, and what's being said is universal for both of them. So again, a term distributes the subject class, and the E propositions um, distribute both the subject and the predicate. So let me say it again. A propositions distribute the subject term, and E propositions distribute both the subject and the predicate. Now, this will become um, more useful information when we go on to talk about categorical syllogisms, or how different sets of statements relate to one another. And so distribution is an important element in understanding formal logic, particularly categorical syllogisms. Now, to go on to the I statements say that some things are part of another set of things. So there are some dogs that have black hair. But you can see from that that the I statement doesn't distribute anything, because it's not talking about all dogs. It's talking about one small subset of dogs which have black hair. It's not talking about all black things. It's saying that some dogs are members of a group of things which have black hair. It doesn't tell you anything else more about the other things. And it doesn't tell you anything more about the other dogs. So in the I proposition, neither subject or predicate is distributed. Now for the O, you say some dogs do not have black hair. So obviously the subject term is not distributed. You might say, well, okay, then maybe the predicate is not either. But no, think about it. If you say some dogs do not have black hair, that means among the predicate class here, we can say certainly among this predicate class, among all of them, there are some dogs that don't belong there, some that do not have black hair. Among all these black things, there are some dogs that don't belong in this predicate class of things with black hair. So actually, it does distribute the predicate. So O statements distribute the predicate. So we can summarize this by saying universal statements distribute the subject, and negative statements distribute predicates. So that's why the E is both universal and negative. It distributes both subject and predicate. The A is just universal, affirmative, it distributes the subject. And the O is particular, negative, and so it distributes only the predicate. So, yeah. Based on this, then, logicians, philosophers have just constructed what's called the square of opposition. And there's both a modern square of opposition and a traditional or Aristotelian square of opposition. So the way it works is like this. The modern square of opposition is the square which is based upon Boolean or modern logic. And for whatever variety of reasons, uh, modern logicians say that this square of opposition, these statements do not necessarily refer to things which are existentially real. They don't have existence. So from a modern perspective, you could make the statement all SRP and all ER, no ERP, no, all SRP and no SRP, and they're not necessarily contradictory to one another, because if you take something which is hypothetical, say uh, all flying zebras are green, okay, you could say that, and you could also say no flying zebras are green. But since flying zebras don't exist, the modern point of view is, well, they're both true, but they're vacuously true because the subject class of flying zebras doesn't exist. So it has no existential significance. It may have significance in terms of logic and how you apply it, but it has no significance existentially. For that reason, if you say all men are mortal and some men are mortal, you'd have to, common sense wise, you'd say, well, yeah, I mean, if all men are mortal, I guess some men are mortal. But from again, from a modern point of view of modern logic, those two things don't relate because they don't have existential import. So the fact that you say all men are mortal says nothing about actual men, real men. Okay, so there's no logical relationship, therefore, between the A and the E, or the A and the I, or the E and the O, or between the I and the O. That some dogs have black hair, some dogs don't have black hair. These things are logically independent of one another. However, both the traditional viewpoint and the modern standpoint agree that these things here, the corners here, are contradictory. Because if you say all men are mortal, you're saying that all men, all the S, are in the P circle. Whereas this O says that there are some things which are not in the P circle. So there are some men who are not mortal. So that is a logical contradiction that can't be. If because if you say there's at least one man who's not mortal, that means there's got to be one here. So the particular statement does indicate that there is a thing which exists. That X indicates there's at least one thing existing there in that S uh, class. So obviously, if all men are mortal, it is logically contradictory to say that some men are not mortal. At the same time, if you say no dogs are fish, it's a logical contradiction to say that yes, well, no, there is a dog right there who's a fish. So, from the modern standpoint, you can't really determine any logical relationship between these categories, except, or these propositions, except the A and the O are logically contradictory, and the I and the E are logically contradictory, which means if one of them is true, the other one has to be false. And if one is false, the other has to be true. Now, um, so here's the point. This is the modern point of view, and so from the modern point of view, if you ask a question about if all men are mortal, are some men then mortal? From the modern standpoint, you cannot draw that conclusion. However, from the Aristotelian or traditional standpoint, you can, because Aristotle said these relationships have a logical relationship if and only if what you're talking about exists, actually has existential import. So if something has existential import, it means it really exists. So you can look at this in terms of Venn diagrams, and you can say, well, for example, if all SRP, if all men are mortal, then if they really exist, then obviously there has to be at least one man here and here in this category. And what logicians do to explain this, they put a little circle around here, meaning that in the universal, there's at least one particular man who exists, who's real, and therefore that is similar to that. So therefore, the A statements are similar to the I statements if and only if you're talking about real things. And the same thing here. If there are no S, which are P, if there are no dogs, which are fish, that means if you're talking about real things, then there would be at least one dog who's not a fish, and therefore it resembles the O statement. So the O and the E and the A and the I have a logical relationship. Now, but the point is, and here's very important, logicians like to say the truth flows downward. So what that means, if you say all men are mortal, well, let's use a different example, which is a real thing. I think men are mortal, but anyway, I want to use dogs for a second here. All dogs are mammals, all right? So if all dogs are mammals, then obviously some dogs are mammals. So we know this to be true. So therefore, you can say quite clearly if this A statement is true, the I statement is also true. However, if you say the I statement is true, that some dogs are mammals, then it's very hard to determine the relationship to this is undetermined. I'll tell you why. Let's use a different example. Some dogs have black hair. Some dogs have black hair. All right. We can say if we assume that that's true. I had a dog growing up who had black hair. Her name was Daisy. She was very nice. She could almost talk. She was almost human. Great dog. Anyway, some dogs have black hair, meaning there's at least one dog which has black hair. But that tells you nothing about the other dogs. Nothing at all. So that's why uh, we say the truth flows down, but truth doesn't flow up because you can't tell the universal from the truth of a particular. Right? However, falsehood flows up. If it's false that some SRP, then obviously it would be false that all SRP. So uh, if it's false that some men are 20 feet tall, if that's false, then obviously it would be false that all men are 20 feet tall. And one way, if you encounter a question about this, like if you're given a universal statement and what is the relationship to the particular statement, just fill in a real thing. Uh, I think sometimes people get really confused when they're taking logic tests, quizzes, and they see S and P and A and B and so forth. And you say, "Oh, I don't know, it's too confusing." No, just take a real thing and plug it in to the subject and predicate class, whether it's S and P or A and B or whatever it is. Plug something real in there. So if you say some dogs are fish, and you say, well, that's false. That's crazy. No dog. That's not true. It's not true. It's false that some dogs are fish. Well, then obviously, if this I statement is false, that some dogs are fish, then obviously the statement all dogs are fish would be false also. So falsehood flows upward. Now, if you do it the wrong way and you say that the a false, if you say it's not true that all dogs have black hair, like all dogs are black, no, that's not true. Are some dogs black? The logical relationship there is undetermined because you don't know, right? So if the universal statement is true, then the particular statement is true. And you can draw that conclusion according to the traditional standpoint. But you cannot draw the opposite conclusion that if this is false, then this one's false, because it may be. And when you do that, it's called an illicit subalternation. So this relationship here is called subalternation, meaning it's the particular under the universal. So this is a subalternation relationship, the O underneath the E. And so again, in subalternation relationships, if the universal is true, the particular is also true. But if it's the other way around, if the particular is true, it doesn't tell you what the universal is. However, if the particular is false, then obviously the universal is also false. Right? So if you say some dogs are fish, and you say, well, that's crazy, that's not true. Well, then if some dogs are fish is false, then the statement all dogs are fish is also false. Now, between the contraries, A and E, according to the traditional standpoint, there is a relationship. Um, and that is, they cannot both be true. You cannot say that all dogs are mammals and no dogs are mammals. So if one of them is true, the other has to be false. However, they can both be false. If you take, for example, let me think, something that's both false. Um, if you say all men are 7 feet tall, okay, all SRP, all men are 7 feet tall. Well, if you are aware of some people, men who are adults, you realize that that's not true because not all men are 7 feet tall. In fact, very few are, unless you play basketball. But by the same token, if all men are 7 feet tall is false, if you say no men are 7 feet tall, that relationship is undetermined. And just from practical experience, we know that some people, especially those in the NBA, some of them are 7 feet tall. Um, so these cannot both be true, but they can both be false. All right. Now, in the I and O statements, they can both be true, but they cannot both be false. All right. So if you say um, some horses are green, some horses are not green, well, probably the O statement is true. Some horses are not green, but um, you could say some horses are brown, some horses are not brown. So they can both be true, but they cannot both be false. All right? They cannot both be false. So these can both be false, but if one is true, the other has to be false. And here, they can both be true, but they can't both be false. Right? So if you say, some dogs are black-haired, it doesn't tell you anything logically about other dogs. I mean, yeah, we know from experience that some dogs are not black-haired, so, but there's no logical, because you could talk about something else that's not common. Um, some swans are white, some swans are not white. Is that true? At one point, people thought, no, that was not true. So the point is, these can both be true, but they can't both be false. One or the other may be true, but they can't both be false. These can both be false, but they can't both be true. Now, the contradictory relationship is the same as in the modern standpoint. If the A is true, the O cannot be true, and vice versa. If the O is true, the A cannot be true. Um, uh, if some dogs are not black-haired, then all dogs cannot be black-haired. But if you say all dogs are mammals, then it cannot be true that some dogs are not mammals. And the same thing with the E and the I. The contradictories, the relationship is the same. If you're talking about, but if and only if, according to the traditional standpoint, this only is correct if you're talking about real things. So Aristotle would say these relationships are conditionally valid if the thing you're talking about actually exists. Then it's valid. For Boolean logic, these relationships are just valid. They're completely valid, and there's no invalidity there because Boole doesn't care about real things anyway. All right, so uh, that tells you a lot. Is there anything else? Let me look at my notes for a second, see if there's anything else I want to cover in this. Yeah. So once again, the A and the O, the I and the E, in modern logic are unconditionally, the relationship is unconditionally valid. It's absolutely valid if one is true, the other is false. But in traditional point of view, they're conditionally valid, and they're truly valid if they're actually talking about real things. So again, to summarize, what's important here is for logicians, what is the quantity, what is the quality, and what is the distribution? Are they universal or particular? Are they positive or negative? And do they distribute the subject term or the predicate term, or both, or neither? Um, I hope this helps with people who are studying logic and are trying to understand the logical relationships between different subjects and predicates in these categorical propositions. Uh, Honestly speaking, learning logic is a lot like learning a new language. Um, and sometimes you study it and it can be confusing to some people. But if you get the language down and understand what the terms mean, and then you can put them in your mind in, into real things, then you can see the association between these real things, and you can pretty much figure out the relationship between these different propositions. Okay, all right. So that sums it up for now. Um, I will have a second part of this video, part two, which is going to be again on categorical propositions, but on conversion, obversion, and counterposition, which is something else that logicians like to play with, how you know mix terms around and figure out what they mean, whether they're true or not true, whether they're valid or invalid. So that will be the subject of my next video. All right, thank you. Stay safe and be healthy.